بسم الله الرحمن الرحيم رب زدني علما.
So now the next thing we'll try to understand about the protocols. Now just now we discussed that the dynamic routing is where the routers will advertise its own information to the neighbors. So the router A will learn about 50 dot network dynamically from all the possible routes, and it is going to do automatically calculate the best route. Any one will be considered as a best route, and if that best route goes down, automatically it will start using the second best route, right? So we said that these all things are automatically done by the router, and the router is going to do it based on the protocol. So at the back end, we have to enable the protocols. So it's not like that you just simply bring the router, connect the router, it will start working automatically. That's not going to happen. You have to enable and you have to decide any one protocol for this process. So there are different protocols are available uh, in the general develop in general. Like we have RAP protocol and EIGRP protocol, OSPF, ISS, BGP. So there is a categorization of these protocols. Means at the end you will be running any one or two combination of the protocols, but overall, whatever the protocol we use, the way the protocols will work will be different. Like if I use RIP protocol, then the RIP works differently compared to EIGRP or OSPF again. Okay. So the first thing what we will be doing is before we get into the individual protocols and understanding how they work, and of course we are not going to see all the protocols at one time. So we need to understand the behavior wise. In terms of behavior wise, the protocols has been categorized into three types. So we have something like the distance vector protocol and the link state protocols, and then we have something like hybrid protocols. So the main thing here is in terms of behavior, these are the categories. So you can see there is a RIP protocol. Like RIP was the first protocol which was introduced, and then there's a version 2. EIGRP was introduced by Cisco and then introduced enhanced EIGRP. So like that, there is a link state protocol. So the main categories can be distance vector, link state, and path vector. Or there's one more category, you can say hybrid protocols. We can say that is one more category you can add here, which is mostly like an EIGRP category. But the basic category is distance vector and the link state protocols. So let's try to understand the difference. Now, the first thing we need to understand, like the behavior. So to start with, this is a basic table which is going to differentiate all these protocols based on the way they work. Okay, based on the way they work, we can say. So the distance vector protocols, like if you're implementing RAP or IGRP protocols, which are no more used, they are like obsolete, no more used, and you don't see them running in the today's production scenarios because there are a lot of limitations. So the algorithm at the back end, they use something called Bellman-Ford algorithm. That is again the name or the calculation used based on the hop counts. Hop counts means it will count the number of routers. Again, when we see the RAP protocol, we'll see the exact way how it works. And again, if you use OSPF or ISS protocols, which are most common inside the service provider networks or inside most of the companies prefer this OSPF protocol, it uses some other algorithm called Dijkstra algorithm, which is again going to build a full topology based path for calculating. And again, when we get into the OSPF, we'll also try to see that, because here I cannot explain you this entire process, how it goes. So basically first we need to understand what is the name of the algorithm used in different categories. Now later on, what Cisco did, Cisco introduced something called hybrid, the dual algorithm, because the Cisco initially introduced IGRP, Interior Gateway Routing Protocol. And that time you also have the OSPF, which was commonly used, which uses link state protocol. So the Cisco combined the best of both and introduced with something called enhanced IGRP. So you'll see the Cisco using this Cisco proprietary protocol. We can say it was developed by Cisco. It was proprietary, but now it is a standard as well. But majority of the other vendors, they don't support EIGRP. So if you're running in a Cisco environment, you might see the EIGRP, But again, you will see the OSPF is most commonly used in today's scenario, which is again a standard protocol. Standard means whenever we use a terminology like standard means any vendor, it works with any vendor. But whenever you say proprietary means it only works with the specific vendors. Like Cisco proprietary means it works only with the Cisco devices. Okay. So in today's network, you don't see this distance vector because there are many reasons we don't use a distance vector in today's scenario. Like there are few things like if you try to see the basic differences, like the updates are periodic. Now, what is the meaning of the first thing? The algorithm difference. Algorithm is nothing but the way it calculates the best route, or if the best route goes down, how it's going to calculate the second best route. So that entire process is combined in the algorithm. Now, if you see here, the updates are periodic. Periodic means, let's say we are connecting two routers. Okay, so every router is going to send out a periodic update. Update is nothing but whenever update is nothing but information about the networks. Whatever the networks you have, you are just providing the update. Now, in the case of distance vector, the periodic updates, like there is something like 30 seconds or 90 seconds. For every 30 seconds, it's going to send an update, which is not required. Okay, so that is what periodic update. Periodic means there is a time interval fixed for every update. Whether there's a change or there is no change in the network, you will be sending the update, which is going to increase the CPU resources, which is something the problem with the distance vector. Now, whereas the most of the today's protocols which we use, either we use a link state or hybrid. Again, as I said, hybrid is just a term used by Cisco to just tell that we also have an EIGRP protocol which will support the best of the link state. But basically here the updates will be incremental. Incremental means whenever you connect a new neighbor, it will send the update. And the next update will be only sent whenever there is a change. Now change means whenever there is a new network added, then it will send the update. It will not send update periodically. But again, there will be a periodic hello messages which will be exchanged. We'll see these hello messages when we get into the individual protocols. Like OSPF sent for every 10 seconds hellos, EHRP sent for every 5 seconds. There will be hello messages, which is just like a keep alive messages. Are you there, neighbor? Are you there or not? So for every 5 seconds or 10 seconds, the neighbors will exchange the hellos, but they don't exchange the update. But whereas here there are no hellos, there is a periodic update for every 30 seconds. Anyway, when I cover the RAP protocol, you will get more clear picture on these behaviors. Now again, whenever it sends an update, it will exchange the complete routing table. But whereas here only the partial routes, which means like here the update is sent for every 30 seconds. And for every 30 seconds, I'm going to exchange the complete routing table, which means I have sent the routing table just 30 seconds before. Again, it will send again complete table, again a complete table, again like that, just a continuous updates. And while for every update, it will exchange the complete table. But whereas in the case of link state, only it will exchange the missing routes. Missing means, let's say there are 5 routes which has been sent in the update. And the next update will be sent whenever there is a change. And that too, whenever, and in the next update, it will only send only the changes. It will not send everything. That is what the incremental updates along with the missing routes. And one more thing, I'll just come to this classful, classless separately. We'll keep this point separate. I have that in the next slide. I'll just leave this one right now. We'll be covering that separately. What is the difference between classless and classful? Now, in short, the classful is nothing but it supports only the default subnets. And whereas the classless, basically they support subnetworks. If you remember, we did the subnetting VLSM designs. So if you're implementing VLSM designs, basically in today's scenarios, we use them. So they support the subnets, whereas here, the classful, they don't support the subnets. But again, the backend, why it will not support that, again, I'll explain you separately. What is the reason behind it? Because they don't, in other words, they don't carry the subnet mask or the subnet mask like that. Like there is a point. Let me just quickly conclude that. Now, the difference between the classful and the classless is The classful protocols are no more used. Like the example, we have RAP version 1 and IGRP. These are no more used. So when the router is sending an update, in the classful, it will not send the subnet mask information, which means it will only send the network ID and there is no subnet mask information. So what will happen is the router 2 receives a network with 192.168.1 dot network and there is no subnet mask information. So what it is going to do? So there must be a subnet mask information, right? So it is going to write down the mask of the receiving interface, which means normally when I say if I give this address and if I tell you that, this is what the network ID is, we generally take it as a C class and we write it as a /24, right? That's what we do in general, but that's not how it works. It will see the receiving interface subnet mask. In this example, the receiving interface is /8, so it will write down /8. So whatever the mask present on the receiving interface means whatever the subnet mask. Like most of the interfaces will have a /30. So if it is a /30, it will write down /30 instead of 24. So what exactly we are trying to do here is we are actually giving the wrong information. Okay. So before we used to use FLSM or we used to use the default subnets, like I use C class everywhere, then it's okay, that's not a problem. But once the subnetting was introduced, now this behavior is not really a good option because it is like providing the wrong information to the routing update. So that's the reason most of the today's protocols, they are not classful. They don't support like the protocols, like I said, RIP and IGRP, they are no more used. They support either the FLSM designs or the default used with the same class. So in today's network, all the protocols, we call them as classless. Now, the meaning of classless is nothing but they will carry the subnet mask information along with update. So which means when the router 1 is sending an update, it will write down the subnet mask information, which means now the current protocols, the updates will be sent with the exact mask. So now it is very clear, right? When the router 2 receives, it knows that I'm receiving 192.168.1.0/24 or 192.168.1.0/28. Whatever is present, exact mask information will be added to the update. So that is what the main difference. So the current protocols which we use, they all support the subnets, VLSM, FLSM, everything it supports. And the reason, because they will carry the subnet mask information. Okay, so that's what this basically the point says here. The routing type, they are classful, which means they don't carry the subnet mask information along with update, which means they only support the FLSM designs or the same network sizes. But whereas when we say classless means it will carry the subnet mask information along with update, and they do support all your FLSM, VLSM, all the designs, which is something we use in today's scenarios. Okay, so the behavioral differences we need to understand in terms of, especially when you're preparing for interviews or when you're trying to figure out the differences between them. Other thing, the communication. Now, communication means, let's say we have two routers. Now, these two routers are sending an update. If you remember, I said they will send the update or they will send the hellos. These will be broadcasted. Normally, it will broadcast out of all the interfaces, which is something not the efficient way of communicating with a neighbor. That's the reason, again, that is another drawback. So in the case of link state or the hybrid is same, there is no much difference, just a few changes. Now, in the case of link state protocols, mainly they use a multicast, like OSPF uses 224.0.0.5 and 6. There are special addresses reserved from the class D, which is specially reserved for identifying that particular routing protocol. And based on that, it can differentiate the updates. But when it is a broadcast, means it's something like to everyone. Okay, so that's really not an efficient way to broadcast. Again, as I said, more in detail, we'll see when we go to individual protocols. Like in the general CCNA, you will see this OSPF is something what is covered. Again, RIP is not covered, but I'll be covering the RIP in the CCNA as well, because that is to understand. And again, when you jump into the CCNP, you will also see some other protocols like EIGRP or, and again, ISS is more covered in the service provider domain, because typically the customers, they don't use the ISS routing, and OSPF and the ISS are the commonly used protocols inside the service provider. So if you're working for a service provider domain and if you're learning the CCNA, CCNP service provider tracks, then you have to be very, very expertised in these two protocols. And OSPF is the most important protocol because it is commonly used in most of the customer networks, OSPF, and also it is a more complex protocol as well. Complex or difficult, we can say. Anyway, once we come to the OSPF, we'll understand why it is difficult, because there are many things you need to get into, or there are many behaviors you need to understand how it works and the configurations and other things. Okay, so when it comes to the overhead, now the other differentiation we can say, like the overhead. Now the overhead is nothing but the amount of CPU and the memory resources it will utilize for processing the routing and the updates, the entire routing process. So most of these protocols are very low CPU resources. That's a good thing. But when it comes to the link state protocols, they generally use more CPU resources because of the designing rules like area. There are many things you need to get into. And again, what Cisco did, Cisco said, I will keep this IGRP protocol. And Cisco, what it did is introduce with something called hybrid. This is not generally a category, but there's a kind of a Cisco name, or you can say an advanced link state protocol. Advanced distance vector, we call it as another name. We call it as advanced distance vector. And Cisco introduced the best of both, like the periodic updates has been replaced with incremental. Full routing table is exchanged with a missing route, same like this. The classful has been removed and classless is supported. Broadcast is removed and added the multicast. So if you see the best of both, and additionally, again, it keeps the same low processing here. So which means it's not going to use the same high processing capabilities here. At the same time, it is more difficult to configure because of the areas and other things. But whereas these are the easy way to configure, means when you add the commands, it looks very easy, very simple, but slightly difficult when we are doing the configuration. And of course, when we get into the configuration, you will understand these points. So initially, just for the sake of differentiation, but once we complete the dynamic routing protocols topic, like once we cover a couple of protocols, you'll automatically understand the differences of this. Okay. So the main thing here, these are actually the categories, the behavior wise, in terms of behavior, like in the case of, in terms of behavior, how these protocols differ with each other. So initially, distance vector protocols was introduced along with link state. But again, we don't use these protocols because of many reasons in today's scenario, like periodic updates, unnecessary full routing exchange, do not support the subnets, updates are sent via broadcast. So basically, we prefer these protocols. So you will be running any of these protocols. So technically, which protocol you have to learn, we cannot specifically say, but OSPF is the one protocol which you must know. So the most important protocol is OSPF. EIGRP is required only if you're running in a Cisco environment, but mostly if you're not running in non-Cisco environment, you don't see this. So that's the reason EIGRP is not covered in the CCNA, but you will see in the CCNP in the advanced routing. ISS, we don't use much on the customer side. So unless you're working for a service provider, you must know these two protocols. Okay. So these two protocols are no more used. So at the end, if you know OSPF routing, you almost know the dynamic routing, okay, because the remaining routings are exactly the similar options. Okay, so this is the same thing, the quick review of the classless, classful will not carry the subnet mask information, classless will carry the subnet mask information, which basically supports subnets as well. Okay, so these are the names, and again, once we jump into the individual protocols, we'll try to figure out the sum of few points. Again, we'll repeat with the individual protocols again.